Hello everybody, welcome back to a new video. I'm so sorry for uploading so late. It is my bad. I'm really sorry. I had quite a lot of stuff going on. But today we're going to be focusing on first principles. And basically what first principles is that we're finding the derivative of the function from the traditional method that was used in 16th, 17th century. And we're going to be exploring how that works, because that's a really key concept in SAYS and I guess a bit in NCA. So, first of all, consider a function y equals f of x, where a is a point x f of x and b is a point x plus h f x plus h. So they're telling us to consider a function y equals f of x, this curve right here, where a is the point x f of x and b is point x plus h and fx plus h. Okay, and they're saying the gradient of chord AB. Okay, we're gonna get later into that. Now, what I want you guys to realize is that this curve, we can find the derivative of this using first principles. But first of all, I want to explain how we get that. Okay, now what we know that the gradient of any curve is rise over run, right? So gradient is rise over run, or it's sometimes written as y2 minus y1 x2 minus x1. Okay, we know that point A is x f of x. Okay, so point x f of x. And we know point B is x plus h and fx plus h. So now that we know this information, what we can do is that we can find the gradient of this slope right here. And what this slope helps you in is that I'll explain it later on, but it's really important that you need to calculate the gradient first. So let our let our x1 be x, and let our x2 be x plus h, and let our y1 be f of x, and let our y2 be fx plus h. So now what we're going to be doing is we're going to be using this formula and substitute the values in. So y2 is fx plus h minus y1 minus fx. x2 is x plus h, and our x1 is just x. So now that we have this, we can simplify this further on. So fx plus h minus f of x, obviously that can't be simplified, but we can simplify the bottom part. So x plus h minus x, which is just fx plus h minus f of x over h. That's it. So now you know that the gradient of point A to B is this. So AB's gradient is this. Okay, now here's the calculus bit. Now we want to find the gradient of this, right? So what we're going to be doing is that we want to make this tangent infinitely small. We want to make it approach infinity. Okay, we want to make it 0. The tangent has to be a value of 0. So what we do is we have a notation called f dash of x, which just means derivative. So f dash x equals limit h approaches 0, and then just the gradient. And this is obviously because we want this to become so small that it resembles this curve. And that's what the derivative is. And that's a concept. Thank you very much for watching, and I hope you found this useful. But yeah.